Okay, so this is lesson 231. We're going to be talking about similarity and conditions that we need to prove them. So this lesson is was designed to be a very hands-on, let's discover, let's figure out which one it is, why it is, what's happening. We're not going to be doing that. So we're going to go through really quickly some of that building stuff, and then we'll move into the actual work. So in During Understanding, earlier in this chapter, we've reviewed the conditions for similarity and how to prove triangles are congruent. Now we're going to do the same thing about similar triangles. So how much information do we need? As we work together, keep in track how much information is needed. Are the triangles similar? How can we tell? And can we create triangles with these conditions that are not similar? We probably won't try that last one very much. So are these triangles similar, and how can we tell? If they're similar, what has to be true about the angles? So we're going to start with angles because that's the easiest one. And so if they're true, the corresponding angles should be congruent and the corresponding sides should be proportional. So I'm going to go ahead and trace the small triangle here and drag it. So since I can't, and I can see, oh yeah, that angle is the same. That angle is the same. And it looks like the side's about 2 times as big. That angle is the same. That angle is the same. And again, about twice as big. We look at this side, twice as big. And so, yeah, all the corresponding angles have to be congruent. The corresponding sides need to be proportional. That is, there's a number I can take the small triangle by and multiply it to get the larger sides triangles. So in this case, I think it's 1 to 2, small to big. Okay, or 2 to 1, big to small. Depends on which way you want to do it. Both are acceptable. Is there a sequence of transformations that can carry one triangle onto the other? And I would say that we can translate it down and slightly to the left and then dilate. And we're going to go down and quite to the left, dilate, and then they will be the same size. Dilate by a factor of 2. So yes. Translate down and left. Dilate with one angle as center of dilation. Wow, I'm awake. Center. Okay, and then we're set. We're all done. Wow, that shadow on my face is weird. Okay, anyway, let's move on. So if there must be an easier way than figuring out everything. Like if I had actually gotten out a ruler and measured, there's just got to be an easier way than doing everything. So what if I only know that the angles are all congruent? What would that mean? And so we're not going to be doing these investigations, but that idea, we want to keep this question in mind. What if I only know the angles? Is that enough? And so in the sequence of transformations show that triangles have the same 3 angle measures. So if you kind of go back here, what I did was just to trace the original triangle, the smaller triangle, and drag it around and check all the angles. That's all I was doing, was translating it and checking the angles. And so I would say that is your range of motion. And again, we're just going to kind of jump over this one. So are they congruent? So here we have 2 angles in one triangle and 2 angles in the other. One of them matches, one's 87, angle J is 87, and so is angle G. So are the corresponding angle measures congruent? Well, right now, angle J is congruent to angle G. And so we need to find the missing angle. And how do I find it? Well, I know 2 of them. So I'm going to subtract. I'm going to take 180, subtract 87, and then subtract 63. If I subtract 87, I get 93. Then I subtract 63. And that's wrong. Something's wrong. A 68. What's wrong is my eyes are not processing. Okay, so 68. and then I will get 25 down here. And so I have 25 here and 87. So this one is 63. I'm going to do the same math to be short, 68. Same math to be short, 180 minus 87 minus 25. So this is 93 minus 25, which is 68. So I don't really have to check that because I kind of know. So yeah, all the corresponding angle measures are congruent once I've established that. So angle I is congruent to angle F, and then angle, and I should use blue, but well, angle H is congruent to angle E. And how many angles do you need? So there's this. So we have two choices. We can have the AAA postulate or the AA postulate, AA or AAAA. So anyway, whichever. And so when I'm looking at this, we actually, because the other angle, if we subtract, is going to be the same, we actually only need 2. So 3 is easy. 3 is enough, obviously, but we only need 2, because if 68 and 25 matched, well, then the other one has to be 87, because they always add up to 180. And so nice, but not necessarily one too many. So if any 2 angles, this is what I'm going to write down conformally. Any 2 corresponding angles in 2 triangles are congruent, then the triangles are similar. The symbol for similar is like the symbol for congruent, but it's just the squiggle. Okay? So congruent is the squiggle and the equal sign, and similar is just the squiggle. Okay? So we move on. What if we only know one pair of angles? So we only know one pair of angles, but the 2 pairs of sides are proportional. And so, again, we're going to skip over this idea, but the thought here, right here, what we're talking about, one angle and 2 proportional sides is kind of the key. Okay, 1 angle, 2 proportional sides. So it asks us to keep going. And that one's a little bit, this one I probably, of the postulates, I use this one the least. But, you know, whatever. So go ahead and record this. If one angle let's see, what is, I'll get the words. Okay. One pair of angles is congruent, but the 2 pairs of corresponding sides that make the angle are proportional. One pair of angles are congruent, but the 2 and, not but, and the 2 sides that make the angle, we would use the word form, or in math, the angle, are proportional, meaning that I can say 3 and 4, and then my other, like I times each of these by, say 6, and I get 18 and 24. That would be a proportional relationship. Okay, times them by the same number. The form the angles are proportional, then the triangles are similar. Okay. So that's our side angle side postulate. And so then we're going to be playing, they would ask us to play games. And you can see why we're skipping this because it would take a long time to play these games. But they'd ask us to play games and decide if if we had only proportional sides, if that was enough, and it is. If all three pairs of corresponding sides are proportional, then the triangles are similar. Okay, and these are the only three postulates you may use for similarity. So for congruence, there are 5. For similarity, there are 3. So the ones we care about are AA, angle and side angle side, and SSS. Now think about the other ones we threw out. We threw out angle side angle, but hey, we have AA. We don't need a side. We threw out angle side angle. Well, hey, we don't need a side. So that's why those 2 are both gone. We don't need sides when we have 2 angles. And but if we only have sides, we need more sides. So just kind of keep that in mind, okay? So that's where we are. And let's see if we can figure it out. So now that we've rushed through the postulates, which we would have spent if we were at school a day developing, I'm sorry about that. We just don't, I just didn't feel like it doesn't work this way. Anyway, are these similarities? So what do you think? So first of all, we've got these 2 angles because they're vertical angles, right? And so that's good. And then these sides, 70 and 50. Now, while they're not directly, that's a little bit funky. It's clear that if I set them up as a ratio, 70 over 50, and the other one is 70 over 50, they're going to be the same, 7 over 5. Okay, so that's what I'm multiplying by, which is a little weird. It's actually 5 over 7, but it's a little weird, but they're proportional. And so I've got, I started with B, I went to C, and then to D. So I went across the line. I don't think this one's going to matter as much because of the sides, but B, C, D, that's my order. So I'm going to start with B, triangle B, and then I'm going to go but, B-U-T, and that will be my order. Okay, and that's that. So moving on to B, we've got 2 marked angles that are similar, congruent, and therefore the triangles are similar. I've got KLM, so KLM, this order. So I started with 1 arc mark, so triangle, 1 arc mark, 2 arc marks, C, so ABC, and this would be AA. So this one was, sorry, SSS, similarity, and this one is AA, and similarity. We don't have an AA congruence, so we don't really necessarily write the similarity thing, but might as well be consistent. On this one, we have sides. So the smallest side is 6, and the smallest side over here is 21. My middle side is 8, and my middle side over here is 28. And then my middle side is 10, and my middle side over here is 35. Dividing these both by 7, I get 3 over, no, by 3, I get 2 over 7. Dividing these by 4, I get 2 over 7. Dividing these by 5, I get 2 over 7. So they are proportional, and we will take a pause. So if you want to go ahead and figure out R, now we have these 2 arrows right here indicating that these line segments are parallel, and that will help us decide. So decide what it is. Again, this one was SSS. Write your congruent statement. Oh, this was SAS. Oh, in between. Write your congruent statement, figure out D on your own. We'll have another video to finish off everything else.